Hi, today's topic is scatter plots, and we're going to look at a scatter plot done based on test scores versus hours studying. But before we begin, I want to review just a few concepts with you. One of the concept is a line written in slope-intercept form. And the reason we want to know that is because when we have a scatter plot, we're going to look for the trend line and see how the y variables, which are test scores, compare to the number of hours spent, the x variables. And so when you write an equation to that line, which is one of the things we're trying to learn here, is we're going to use the form y equals mx plus b. And that m there represents your slope, and the b represents your y-intercept, which is the place where the line crosses the y-axis. So, one of the things before we count how many points or how many pieces of data are in our scatter plot, we look to see if there's any outliers. And right here you can see that there's an outlier at 0.5 75. So what that means is there was a student who only had to study a half an hour, and they scored a 75 on the test, where most of the students had to study for a longer period of time to do better on the exam. So this person here, and I've used a different sticker to represent this person that was able to score high without much studying, as the outlier. Okay, so that heart there represents our outlier. So when we count our data points, ignore that point for determining where the line of best fit should go. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 outliers. And since there's 10 outliers, we want to try to divide that into 2 equal parts. So when you're putting in a line of best fit, you're trying to get the data divided into 2 groups that are the same. And so you either have to put 2 points on the graph to draw your line through, or use points that already exist. Now it looks like if I were to put a piece of string up here to look for where my line of best fit, if I use 0, 35 and 5, 100, which is already in the data set, that it will divide the points fairly equally, so that we have 1, 2, 3, 4 above it, 4, and 1, 2, 3, 4 below the line. So we're going to use those 2 points as our to help us draw our line of best fit through. So we'll put a piece of tape right there, and we'll put a piece of tape here. Okay, so you can see that the line of best fit divides the set of points into 2 equal groups. Now, what you're trying to do with that line is be able to make a prediction of what's going to happen. And so if you studied 3 hours, it looks like you would typically score about a 75 on the exam. When you do that, when you're trying to decide what happens between the points, that's called interpolating the data. And so we try to make predictions and based on that line, what could happen in the future. So the next thing I want to talk about is writing an equation to this line. And so there's 2 things we need to know. We need to know the slope, which is m, and we need to know the y-intercept, which is b. And the y-intercept is the point where the line crosses the y-axis. So that we have figured out. We know that our b is going to be equal to 35. Okay, our slope we can calculate by using the 2 points, and the points was 5 hours. So somebody studied 5 hours and they scored a 100, and somebody studied 0 hours and scored a 35 on the test. So the way you calculate this is you subtract the y values, so 100 minus 35 divided by 5 minus 0. So when you take 100 minus 35, you get 65, and 5 minus 0 is 5. And then you're allowed to go ahead and reduce your slope. So how many times will 5 go into 65? Let's see, once with 1 left over, so 13 times. So m equals 13. So you know your slope. So basically that's what that's telling us, is for every hour you study, your test score went up by 13 points. So when you write an equation to model this situation, you would write y equals 13x plus, and we started at, our initial score was 35, so plus 35. A lot of times we're asked, what is the slope? What does it mean? The slope represents a rate. Every time you're looking at a graph like this, that line is a rate comparing the y data to the x coordinates, or the x data. And so we have a rate that goes in front of x. So this is 13. And then the other question is what is the y-intercept? And the y-intercept in this case is the initial amount scored with 0 hours studied, so it equals 35. So hopefully this will help you as you write equations for the line of best fit when making scatter plots. Thank you.